Hi, grade 12. So today we are looking at a special case of our previous lesson. So same question, just a little bit different in our answering of the question. So it says here, how many terms are there in a geometric sequence? So they tell us it is a geometric sequence and they give us the last term of the sequence. So let's start. Step number 1 is to find the general term. So this formula you get on your formula page. A refers to the first term, so we can see our A is 5 and our R is T2 over T1. So R is equal to negative 15 over 5, which is negative 3. So now I go back to my general term. I make A 5 and R negative 3 to the n minus 1. Then I take this general term and I make it equal to the last term. So this is the last term. And from here, I do algebra. So now, I need to solve for n. So first thing, I'm going to divide by 5 because I want to cancel these two 5s. But what I do on the right, I do on the left. So I'm going to be left with negative 3 n minus 1. And on the left-hand side, I'm left with 6, 5, 6, 1. I have to make the base numbers the same now, eh? Remember I said on the calculator we put in 6561 equal, shift, and then we look for fact. You see it says 3 to the 8. The problem is grade 12s that we don't have a 3 as a base, we have a negative 3. So I'm going to show you something, eh? So I'm going to write this as 3 to the 8 is equal to negative 3 n minus 1. But what I'm going to do now is I'm going to add a negative in front. So I'm going to add the negative and close my brackets. So I want to show you that whenever the power is an even number, you can add a negative in front if you need to. So let's check. So I'm going to open a bracket, negative 3, close the bracket to the power of 8. Look there, you get a positive 6561. So whenever you have an even power, you can add the negative. Okay? Now that the base numbers are the same, we drop the base and we solve for n. 8 plus 1, n is 9. So therefore the answer is there are 9 terms in the sequence. And that's how you do the special case.